Hello everyone. If you are a civil engineer or quantity surveyor, you have likely encountered the challenge of creating bill of quantities while facing tight deadlines. Sometimes you might only have 2 or 3 days to submit quotations. In today's video, I'll show you how to efficiently create a BOQ in just 5 minutes. Let's get started. Now here I have opened an Excel file in which I have created a format for you to calculate the quantities of different items for the bill of quantities. This format is only applicable to high-rise buildings with a range of 10 to 20 stories with a minimum of 2 basements to a maximum of 3 basements. I have provided the link to this sheet in the description. You can download it for your personal use. Now to use this format, you just need to insert the covered area of the item and multiply it with the given factor range. For example, let's consider a 15-story building with 2 basements. The total covered area of the building is 1,50,000 square feet, in which 5 floors including 2 basements have an area of 12,000 square feet and 10 floors have an area of 9,000 square feet each. We all know that in the construction process, the first step is excavation and it proceeds with compaction, leveling, and dressing. And just like that, the bill of quantities format reflects the sequence with excavation as in the initial term. However, in this video, we will exclude the excavation and start from the plain cement concrete. The thickness of PCC 148 in the foundation is normally 4 inch to 6 inch, and here I have provided both options. The bed area of PCC is 12,000 square feet and the range for 4 inch PCC that I have given is 0.33 to 0.40. Normally we use factor of 0.33, but on the actual side the consumption of concrete may be more than the calculated amount due to concrete wastage, lack of supervision, uneven areas, or other reasons. Therefore, you should multiply it by a factor greater than 0.33 and less than 0.40. In this example, I am using a factor of 0.33, resulting in the quantity of 3960 cubic feet for the 4-inch thick PCC. If you have PCC with a thickness of 6 inch, then use the specified ranges accordingly. Now, after the plain cement concrete and providing a membrane layer for waterproofing, the next step is screeding of 2-inch thickness. The covered area for screeding is also 12,000 square feet and the specific range for it is between 0.16 to 0.20. After multiplying 0.16 with the covered area, you will get the quantity of 1920 cubic feet for screeding. The next item is reinforced cement concrete for raft with a depth of 60 inches. The covered area remains the same at 12,000 square feet and the factor range is given from 5 to 5.10. This range includes the calculation for the raft and other consumptions such as lift walls, some pits, underground water tank walls, septic tank walls, and also the concrete consumption resulting from the height difference between the lift and the raft. Now I am going to multiply 5 with the covered area and by doing it we'll get the value of 60,000 cubic feet for the raft concrete. Next, I have provided you the options for different sizes of raft along with the factor ranges. Multiply these factors with the covered area to obtain the respective quantities. Now let's calculate the concrete needed for all other structural members such as columns, slabs, beams, retaining wall, lifts, stairs, lintels, band beams, parapet, underground water tank, overhead water tank, some pits, etc. For the calculation of these members, add the covered area of all the slabs only. There is no need to calculate the quantity of column, retaining walls, or parapets separately. The total covered area of the building is 1,50,000 square feet. Simply add this to the column for the covered area. I recommend multiplying it by a factor of 1.15. By doing that, you will get the quantity of 1,72,500 cubic feet for all these members. Now the next item is steel. The covered area is 1,50,000 square feet and the given range for it is 6.75 to 8. Different designs for steel may have varying factors due to over design, under design, or balanced design. The provided range can be used based on the appropriateness, but I recommend leaning towards the higher side. Typically, in buildings between 10 to 20 stories, the steel consumption is around 7 kg per square feet, encompassing steel for all members, including raft, band beams, or any other member. In this case, I am multiplying the covered area by a factor 7, which will give us 10,50,000 kg of steel. The next item is block work. For block work, add only the area of the slab in which blocks will be utilized. Normally in high-rise buildings, block is not used in basements due to parking, and also we neglect the floors in which the utilization of block work is up to 5%. In this case, deduct the area of two basements where one has an area of 12,000 square feet and two have 24,000 square feet. By subtracting 24,000 from the total area of 1,50,000 square feet, we will get the covered area of 1,26,000 square feet. The range given for block work is from 0.75 to 0.90, and we will multiply this covered area with a factor of 0.75. And by doing that, we will get the block consumption of 94,500 cubic feet. After completing the block work, the next item is ceiling plaster. In high-rise buildings, we typically provide false ceilings. Therefore, there is no need to plaster. However, for the sake of understanding, we are calculating the ceiling plaster. Add the area of 1,26,000 square feet because plaster is not done in basements. Multiply it by 0.80 and we will get the adjusted area of ceiling plaster as 1,08,000 square feet. The next item is wall plastering. To determine the required plaster area, add the total covered area of the building, which is 1,50,000 square feet, and multiply it by a factor of 3. The factor should not be more than 3.25 and not less than 2.25. By applying this multiplication, we obtain the plastering area, which is 4,50,000 square feet. After calculating the wall plaster, the next item is external plaster. For external plaster, add the area of 1,26,000 square feet as the walls of basements that required plaster are below the ground level, making it impractical to plaster them. By multiplying this area by 0.5, we obtain the external plaster, which is 63,000 square feet. The next item is plain cement concrete for 2-inch thick flooring on each floor. To calculate the quantity, add 1,50,000 square feet and multiply it by 0.16, resulting in the volume of 24,000 cubic feet. With all quantities now determined, the next step is to compile them in the Bill of Quantities. Insert the respective rates and your BOQ will be ready. If you are unsure where to find the rates, I have already covered that in a video that you can watch at your convenience. That concludes today's session. Thank you for watching.